So link aggregation, the topic is link aggregation, is going to help us understand how we can be able to combine multiple physical links so that they can act as a single logical link. At the aggregation and at the core layer, most of the time we implement redundancy between peering devices. And when we do that, we might want to combine those physical links into a single logical link. So that is it about link aggregation. And it brings about several advantages, which we're going to see in a short while. So as a means of optimizing the throughput of data, link aggregation enables the binding of multiple physical interfaces into a single logical pipe. This effectively introduces solutions for providing higher utilization of available links, as well as extended resilience in the event that failure of individual links are to occur. Engineers are required to have a clear understanding of the conditions that define the behavior of link aggregation and the skills and knowledge for its application. To ensure effective link aggregation solutions can be applied to enterprise networks. By the end of this chapter, you should be able to, number one, explain the use of link aggregation in the enterprise network, describe the various forms of link aggregation supported, and you should also be able to configure link aggregation by the end of this chapter. So link aggregation. Link aggregation is when we do this, we provide several physical connections between switches or routers. Like here we have three different physical connections between switch A and switch B. We do that in order to provide what we call network resilience, so that if one link goes down, if we just had a link, a single link, and it goes down, then people will be isolated. Either people who are connected to switch B or people who are connected to via switch A. They'll be isolated. They'll not get network services. But most of the time, we implement this, which we call redundancy. We implement redundancy in order to make the network resilient. Resilient, especially to failures. Now, when we have redundancy, we can actually combine these three physical interfaces to work as a single logical interface. So we combine multiple physical interfaces to work as a single logical interface. That is what we call a trunk link, or sometimes you call it an Ethernet, trunk, or simply an ETH trunk. Now, link aggregation provides several advantages, one of them being increased bandwidth. What does that mean? If this interface offers 100 megabits per second as the bandwidth, this one 100 and this one 100, because all of them are Ethernet interfaces, then in total, the logical link, the Ethernet trunk, will provide 300 megabits per second. So you see, when they are combined, they offer increased bandwidth. The next one is they help enhance reliability. That is, if one link goes down, the others will still be forwarding data. So no users are going to be isolated on the network. And finally, link aggregation also supports what we call load balancing. That is, data is forwarded equally between all the combined physical interfaces, as we are going to see in the next few slides. So how does it work? How does it work? So application in the enterprise network, as you can see, most of the time at the core and aggregation layer, we provide redundancy. So most of the time when we do redundancy between peering devices that are on the same layer, it is highly advised that we combine those particular logical links to act as a single link. And generally, we do this at the core and aggregation layer because this is where all the data will congregate before they go to the internet. Uh, So where traffic from all parts of the enterprise network congregates, that is where it's actually ripe to do link aggregation. So we may not do link aggregation at the access layer switches, because access layer provide connectivity to the end devices or hosts. So most of the time we only do it at the core and at the aggregation layer. So let's look at the link aggregation modes. We have two link aggregation modes. The first one is called the manual mode. The second one is called the LSCP mode. It is important to emphasize that the LSCP mode is also commonly referred to as a static LSCP mode. Static LSCP mode. LSCP stands for link aggregation control protocol. Link aggregation control protocol. So LSCP mode is generally referred to as the static LSCP mode. Now, in manual mode, you have all the links in manual mode actually forward data in load balancing mode. In manual mode, you set up, you manually create the Ethernet trunk. And the most important thing to remember about manual mode is that all links are forwarding data in load balancing mode. Now, LSCP mode supports redundancy. LSCP mode supports redundancy. How? In LSCP mode, some links forward data, and those links are referred to as active links. And the other links act as backup. So in case an active link goes down, a link that has been acting as backup will actually pick up and start forwarding data. How does the switch decide on which backup link to replace with an active link that has gone down? It looks at the interface priority. So the interface with the highest priority is the one that is going to replace the one that has gone down. For this particular purpose, the LSCP mode is also commonly referred to as the M to N mode. The M to N. So it's commonly referred to as the M to N mode. So why M to N? Where M represents the number of active links, while N represents the number of backup links. So generally, the main difference between these two modes is that in manual mode, every link is forwarding. In LSCP, some links forward, some links don't forward. They act as backup. Sorry. Are you still able to hear me?
Yes.
Yes, yes.
Okay. Now,
Yes.
thank you very much. Okay, so let's move on. So data flow control. So we begin by defining really what a data flow is, and this is a term that you're going to see more and more in coming topics. So we really need to understand what a data flow is. Now, a data flow can be thought of as a group of frames with the same MAC address or IP address. So when we talk about MAC address and IP address, we are simply talking about the source. Are you able to hear me? Source and destination. Hello, are you able to hear me?
Yes,
Yeah.
yeah.
Okay. I'm having issues with my internet, so I'm getting some notifications here. That's why I'm asking, sorry. Okay, so a data flow, a group of frames with the same MAC and or IP address that is on the source and the destination fields of either the data link layer header or the network layer header. Now, generally, frames of the same data flow are actually forwarded over the same physical link. Frames of the same data flow will be sent over the same member links or physical links. Now, the other thing we need to know here is that in order for you to be able to create a trunk link or an Ethernet trunk, there has to be a consistency on both ends of the peering device on a number of things. One of them being the number of physical interfaces. So if in switch A, you've added 3 physical interfaces, in switch B, you also must have 3. The next one is the transmission rate. The transmission rates. So transmission rates is simply the speeds. So if in switch A, you have Ethernet interfaces that do 100 Mbps. On switch B, you cannot do gigabit Ethernet. If you do that, when switch B is sending to switch A, we will have congestion and frames will be dropped. So the transmission rates of the interfaces that you're adding to the Ethernet trunk must match on both ends. The other one is the duplex mode. You already know what a duplex mode is. And lastly is what we call the traffic control modes. So the traffic control modes can be this. So especially when you're talking about switches, you can have a layer 2 switch or a layer 3 switch. Now, a layer 3 switch will support layer 3 interfaces and layer 2 interfaces. Layer 3 interfaces forward data based on IP addresses. Layer 2, they only understand MAC addresses. So you cannot add a layer 2 interface to an ETH trunk with a layer 3 interface. So that is what we call the traffic control mode. That also has to match on both ends. So I hope that is clear. Okay. So let's see, how do we configure link aggregation? How do you configure link aggregation? So on system view, we enter the command interface, then eth-trunk, then the ID. So you can create many Ethernet trunks. You can create several Ethernet trunks. You can create several interface trunks. Actually, you can have the ID from 0 to 63, all the way from 0 to 63. So after doing that, it will get you into that particular Ethernet trunk you see here with the ID one. Then this is how you add a physical interface. This is how you add a physical interface into an Ethernet trunk. So that's the first way. So here we've just added a gigabit Ethernet. So we are in switch A. So we've added this interface to ETH trunk 1. Then we can go ahead. Oh, sorry. That was not correct. I'm sorry. Let me just repeat that. I'm sorry. Here we are actually typing this in order to go into that interface. I'm sorry. We are typing this in order to go into the gigabit Ethernet 0/0/1 interface. So after we are in that interface, now we can add it to ETH trunk 1 by typing that command. Then again, we go into G002, then we type the command ETH trunk 1 to add it to the interface. So that is how we add physical interfaces into the Ethernet trunk. Now here again, you need to understand a number of things. You need to understand a number of things here. One of them is you can only delete an Ethernet trunk. You can only delete an Ethernet trunk if it does not contain any member interfaces. So you cannot delete an Ethernet trunk if it contains other member interfaces. So you must understand that. The other thing you must understand is that an Ethernet trunk, an ETH trunk supports a maximum of 8 members. So an Ethernet trunk might not have more than 8 physical interfaces. Another one, an interface can be added to only one ETH trunk interface. So a physical interface cannot be added in more than one. So right now, we've added G001 into ETH trunk 1. If we wanted to add G001 to a different Ethernet trunk, maybe ETH trunk 2, we will need to remove it first. We'll need to remove it from ETH trunk 1. So I hope that is clear. The other thing we've said is that in terms of speed, so you cannot add a fast Ethernet interface and a gigabit Ethernet interface in one Ethernet trunk, in the same Ethernet trunk. If you try to do this, Huawei switches and routers will actually give you an error message because they operate at different speeds. So these are some of the other basics about ETH trunks that you need to be aware of. So that was a layer 2 link aggregation configuration. So here we want to see layer 3. So we are creating actually, we are aggregating links between two routers. So layer 3 link aggregation configuration. So again, we create the ETH trunk using the command interface ETH-trunk, then we give it an ID. Then this is the command that is used to change the Ethernet trunk from a layer 2 Ethernet trunk to a layer 3 Ethernet trunk. So undo port switch. Once you've done the undo port switch command, now you can be able to assign the ETH trunk an IP address. You see? Then after that, we can quit. Then we go to interface gigabit Ethernet 0/0/1. We add it to the Ethernet trunk. We go to G002. We add it to the Ethernet trunk. So now, these individual physical interfaces do not need an IP address because they are going to use the IP address of the Ethernet trunk. They are going to use the IP address of the Ethernet trunk. So the physical interfaces will not need an IP address. Okay. So we can always use the display command to confirm. So display interface ETH trunk 1. So we can see that the current state is up, and also the line protocol is up. So the line protocol will be up if everything that is supposed to match is matching on both ends. Then the line protocol will be up, like the speed, the duplex mode, both of them are layer 3 interfaces, and the other one. Then here, it will be up if all the physical interfaces that have been added, their status are up. So here we've added these two interfaces and their status are up. So if one of them, the status will be down, then the status here, the physical status of the Ethernet trunk will go to down. Will go to down. So I hope you'll see that when you'll be doing the lab. And that is it about link aggregation. So can someone volunteer and help us read these two questions, please? I'll just read one and answer it if you're able to. If you're not able to, you can ask someone else to assist.
Yes.
Okay. So if an admin attempts to add gigabit and fast Ethernet in the same ETH trunk, what will happen?
Link will not be able to come up or aggregate.
Yes. You'll actually get an error in Huawei switches and also routers. In order to establish backup member links, which mode of link aggregation should be used?
LACP. mode.
And I want you to be calling it static LSCP mode. Static LSCP mode. Very important. Asante sana.